In this video, we will discuss ways we can classify different types of data. So once we've collected information, then the collected of information is known as our data set. Most data could fit into two different categories, qualitative and quantitative data. Let's look at the differences between these two types of data. Qualitative data tell how much or how many of something there is. So it's the result of counting or measuring attributes of a population. Qualitative data classifies individuals or information into categories. It is also called categorical variables. In our next example, we will classify each of these as either qualitative data or quantitative data. So first we have a person's age. A person's age is an example of quantitative data because we can attribute a particular numerical value to it, 1, 2, 3, 4, 5, etc. So next up, a person's gender. Think about if this would be quantitative or qualitative. This is an example of qualitative data because gender is in the categories male and female. So it's not a numerical one, but it's a category definition. Next, we have the mileage and miles per gallon of a car. So we would measure the mileage as a numerical answer. That's why this is a quantitative example. So next up, the color of a car. Think to yourself, is that quantitative? Is that a numerical measurement? Or is that qualitative, a category measurement? The color of the car, it could be red, blue, black, white, etc. Those are different categories, so this would be qualitative. Okay. Now next up, the final letter grade for a math class. Pay special attention that they did specify letter grade. So we know this is A, B, C, D, E, F. So as a specified letter grade, we have specific categories A through F. So this is another example of data that can be classified into categories or qualitative data. Now, if we're looking at qualitative data, remember qualitative can be split into categories. It could be split into two types, ordinal and nominal. So whenever we talk about ordinal qualitative data, ordinal data are qualitative variables whose categories have a natural ordering. So as you're trying to remember these, think ordinal ordering. The next category of qualitative is nominal, and nominal variables are qualitative variables whose categories have no natural ordering. So it's the opposite of ordinal. And as you're trying to keep these definitions straight, remember nominal has the word no in it, so it's no ordering. Ordinal is the order. So ordinal has an ordering, nominal has no ordering. So looking at our next example, we've got four different types of qualitative data, and we're asked to measure if they are nominal or ordinal. So we've got state of residence, color of car, size of soft drink, letter grades, and a statistic class. Take a moment to think through each of these. Which ones do you think have a natural ordering, in which case they're ordinal data? Which ones do you think don't have a natural ordering, no ordering, in which case they're nominal? So as we think about state of residence in the states of the United States, there's no natural order to the states. They are just the collection of states. So that is a nominal variable, no ordering. Next up, the color of a car. So for instance, blue, red, white, black, there's no ordering to that either. So that is also nominal, no ordering. Now, size of soft drink, small, medium, or large, there is a natural ordering there from smallest to largest or largest to smallest. So since there is a natural ordering, this is an ordinal example. And letter grades in a statistics class, we know A is a higher grade than B is a higher grade than C is higher than D is higher than F. That has a natural ordering. That's why this is another example of ordinal data. So our next category of data goes back to quantitative variables. So remember, quantitative, we can associate a particular number to them. It's measuring some attribute. And in quantitative variables, we have two different types, discrete and continuous. So whenever we think of discrete variables, they're quantitative variables, so there's something that can be measured with a particular number, and the values could be listed out. Now keep in mind the list could be infinite. So as we're thinking of that, for instance, if we were talking about how old a car was, We talk about that in terms of 1 year, 2 year, 3 years. So if we were talking about the age of a car rounded up to nearest year, that's a discrete variable because it is 1, 2, 3, 4, 5, 6, etc. Continuous variables, on the other hand, have value in some interval. However, it's not possible to list out all the possible options because there's not only infinitely many options, which there's infinitely many possibilities in discrete as well in some cases, but in continuous, you could never list out all the variables. So for instance, what we could talk about in terms of continuous is consider the weight of a cat. The cat might be 5 pounds exactly, or it might be 5.001 pounds, 5.0001234 pounds, any different variety of weight. That's the idea of a continuous variable. So let's look at our next examples and see which of these are discrete and which are continuous. And as we want to go through these examples, pay special attention to how it's phrased. So this first one is the age of a person at his or her last birthday. So what they're specifying here is it's not age in general, because definitely age is constantly changing. You could be 13 years old in 1 day, 13 years old in 2 days, 5 minutes, 17 seconds, right? It's not just the age in general, but it's the age at the last birthday. So that was a specific year, 7 years, 8 years, 10 years, 20 years, 60 years. So as it said the age at a particular last birthday, that is discrete. Those will only be whole number answers. Next up is the height of a person. Now the height of a person, we often just use feet and nearest inch for simplicity. However, that's not really representing the reality. Somebody who says they're 5'7", in fact, might be 5'7", 7.002356 inches, right? But we just shorten it for efficiency. But in this case, we're talking about the height of the person in general, and that is a continuous variable because it could be any value between the smallest height up to the highest height and any value in between. Next, we have the weight of a mango. This again is an example of a continuous variable because while the mango might be just 2 pounds, it could also be 2.1 pounds, 2.000005 pounds, any variety. It's not stuck to a certain list of answers. Now, the number of students in class, if we were counting the number of students in class, it would be a particular whole number. There might be 10 students, 20 students, 30 students. It's definitely, you know, the outcome will be one of the numbers 1, 2, 3, 4, 5, etc. and greater. So that's the example of discrete. So in this video, we've reviewed both the categories qualitative and quantitative. And then within qualitative, we reviewed the idea of ordinal and nominal data. And within quantitative, we reviewed discrete and continuous data.